Hi, welcome back to NMI. In a previous video, I was testing and fixing the Tandy 1000TX, and at the end of the video, I started to have issues with the VM-4 monitor. So in this video, I am gonna attempt to fix that monitor. So let's get to it. The first thing that I tried to do was to find the schematics for this monitor, but that was not easy. To be honest, I could never find it. I tried a lot, searched multiple places, and I don't think these schematics do exist. If you have them, please mention in the comment add a link so that I can download them. But so far I could not find any schematics for this monitor, which is a shame and makes fixing it a lot more difficult. Okay, so let's open it up. Hey, before we continue, a word of warning. Please do not try this if you're not comfortable with high voltage and the risks involved in dealing with a CRT. There are risks of electrical shock and hazard in general, so please keep that in mind and only try this if you're comfortable and understand the risks. Okay, I have some stuff for like contact cleaning here, and I like to discharge the flyback first thing. So we're gonna use this 1 mega ohm resistor. Let's do it. Okay, here we have like a general perspective of the video board. I tried to highlight the main areas so you can see the yoke connector, what I think is the vertical circuitry, the BU407 horizontal driver, and the LA7808, which is the only IC in this PCB. I'm also highlighting here some of the main capacitors that are the first ones that I'm gonna try to either replace or test. So after testing multiple capacitors and not finding anything, I decided to take a look at these two diodes, D306 and D307. So when I first removed D306, I found that it's a Zener, an 8V2 Zener, and it tested okay. And when I put it back in the circuit, I noticed that it was working properly on the circuit as well. So I could read that the voltage across the Zener was in fact around 8.2 volts as expected. But when I did the same with D307, I found that that is also a Zener, but it's a 15 volt Zener. But the thing is, the voltage on the circuit is across this Zener is only around 9 volts. So that told me that something is wrong. And following the cathode of that Zener, it is connected to the power supply circuit, the pin that is highlighted here. So I decided to take a closer look at the power supply. So this is the power supply module. There is a transformer. This is the power supply board. That is this is a linear regulator, right? So that is a 2SD313. That is the main regulator, the transistor. This is a big resistor that works with that transistor to perform the regulation, whatever. The AC input comes here, goes through this circuit, goes to the switch here, and then from here it goes to the transformer, to the primary. The transformer, then the secondary shows up here, goes through this full bridge rectifier. This is the filtering capacitor, 3300 microfarads by 25 volts, and then that's it. That goes out on this orange pin here. And so let's make some measurements. I have the video input here connected to my Apple II so that I can have some source of video. I don't have any testing generator or anything, so that's what I'm doing now. So we take the power supply, all the metal is grounded and it's connected to the ground on the board. So I'm gonna connect my scope ground here, the probe ground here, and let's take a look here at the output of the power supply. And is there everything fine there? Yes. So let's connect, and we can see here that this is the output of that power supply. So that is pretty interesting because you can see here there is a lot of ripple, a lot. 120 Hertz, yeah, because it's a full bridge rectifier, so it's double 60 Hertz from mains. Okay, that does not look good. Maybe This is the reason why I see a smaller voltage on that Zener, because it's still like alternating, right? It's post DC. This is not really DC, stable DC. Okay, so that is a good indication. Maybe I waste a lot of time. Well, but I think it's, yeah, well, I was gonna say it's part of solving the problem, trying things out, but maybe this is the very first thing I should have done, tested the power supply. Yeah, I'm not super experienced on fixing these things, so yeah, but that's a lesson learned. Maybe next time you probably want to check the power supply first. Okay, now let's take a look at the other voltage rail that comes out of the power supply. Here, this is looking much better, right? Much stabler DC, 5.45 volts. Yeah, the other one looks really fine. The problem is the orange wire, right? So let's see. Disconnect the power supply, disconnect the monitor, and now I don't have a capacitor that big, right? This is a 3300 microfarad capacitor by 25 volts. I have only smaller capacitors, and that's gonna be a problem. Maybe I'm gonna have to order one. But one thing that I can do is I could just add another capacitor, right, in parallel. So I have a couple 1000 microfarad by 50 volts. I could parallel them with this one and see what happens, because if this capacitor is not good and now my tester died, I have no way to test this capacitor. But if this capacitor is not good, that would be the reason for us to see all that ripple. So let's move ahead, and I'm gonna try to solder another capacitor here and parallel with this one. So let me move this a little bit, and let's make this a little bit more stable. Yeah, so I have a capacitor here. This is 1000 microfarad by 50 volts. I'm gonna temporarily, I'm not gonna leave it like this, but just for testing purposes, let's add this capacitor. Move the power supply unit there to where it belongs, and now I'm gonna reconnect the power switch. Okay, the multimeter is dying, battery is running out. So now let's have a look at the output of the power supply. My scope probe. Oh, this is a mess. I have been working on this monitor for several nights, so I apologize. Everything is really messy here. We're gonna connect to the orange connector, and okay, 0 volts there. Power is not applied. Let's apply power to the whoa, look at that. 25.2 volts, stable, no more ripple. Did we just solve the problem? Okay, that is very good outcome. So, and again, just want to give a big thanks, because the only reason I'm doing this, well, not the only reason, but one of the reasons is because my friends at Discord, Ian, Greg, and Stuart, they're like, oh, maybe you want to try to test the power supply based on my findings, and I totally agree, and that's why what I'm doing here. So, okay, we have now stable stable power supply, right? So I'm gonna move my audio or video input there. I'm gonna reconnect everything. Okay, we don't need this probe for now. Okay, moment of truth. Yes! It worked! Look at this! Amazing! The image is so good again. Oh, I'm so happy. That's it. So it was the capacitor on the power supply. I should have thought about that. I apologize. Well, I have to apologize to myself. But yeah, well, it's a long time since I don't fix this kind of stuff, and I know that the power supply is the first thing. Okay, just got a new capacitor. Let's replace this one. Old one, track on, never heard of it. New one, just arrived from Mauser. Sure that we keep the polarity right. Positive is this side. There's some, but I don't know if that is glue or I'm more leaning towards glue there. Okay, reinstall. I have to remove some of the old Okay, let's trim the terminals. And polarity is correct. Just gonna bend a little bit the terminal so it doesn't fall off. Until I can apply some solder. Okay. Good. Just let me make sure that the capacitor is perfectly aligned. Yep. Now the other terminal. Then we trim the leads again. Okay, good. Good. Now let's trim the excess here. Okay, and that's it. Now we reinstall the power supply and we test the monitor. Okay, before we close the monitor, let's make sure that it's working and that all the, because I changed some settings in the potentiometers inside, so let's make sure that everything is fine and well adjusted. Oh, that's good. The monitor is working fine. Let's see. Oh, okay. So that is, we need to adjust. That might be linearity. Let's take a look. So let's use Deskmate to fill up the screen and so that we can have a better perspective. Desk. Oh. So the drive is not good anymore. Yeah, apparently. The drive, floppy drive, maybe alignment is not perfect. Let's try basic then. Yeah, okay. So we have more area here. Let's oh, much better. Okay, and the linearity, I think, looks good. Yeah, I don't have a way to. Yeah, this is not good, but I think this is okay. Good. Yeah, I think that's it. Now the monitor is working, and I'm gonna just close the case, and that's it. Well, that's it for this video. I'm happy that the monitor is working now. The Tandy is always full of surprises, so now it seems that I have a floppy drive to align, but that is part of the fun. So again, there's gonna be a follow-up video on this one where I'm gonna align that drive and run some other software on that machine. I hope you like this video, so please click on the thumbs up there and subscribe to my channel so you can get notifications when I publish new videos. And that's it. Thank you and see you next time. Bye.